The second topic we're going to talk about today is going to involve the concept of encounter order. So encounter order is a very important concept in Java streams, both sequential streams as well as parallel streams. And sometimes this concept's a little bit mystical to people. So I'm going to explain to you what encounter order is, and then we're going to talk about how to enforce encounter order when it matters and how you can relax encounter order in some circumstances. And oftentimes when you relax encounter order, your program's performance is much better because there's no obligation on the part of the streams framework to maintain the encounter order, particularly in the terminal operations that put everything back together at the end. So let's go ahead and share our screen. We'll get started here. So this particular example is the EX21 example. And here is EX21. So this is going to show off a whole bunch of different encounter order scenarios. We're going to have lots of elements to process, but we're only going to print a limited number of them because it would take too long and you couldn't see the results anyway. And here's what we're going to do. We're going to generate a bunch of random numbers using the typical trick we use with the ints factory method on random that generates a stream of numbers within a certain range. And we're going to do it between 100 and 200. That's the range we're going to generate within. And we're going to go ahead and make ourselves an array of integers. And then just for kicks, just to make it fun, I'm going to turn that into a list. So we're going to have a list of an array. Obviously, there are other ways I could have done this. I was just having fun with different ways of managing and mapping objects with different conversions in Java streams. We're then going to go ahead and create a hash set from the list. And the reason we do this is the list is going to enforce encounter order. That's part of the properties of a list. Conversely, a hash set will not enforce encounter order. That's part of the properties of a hash set or a set. Also keep in mind that a hash set or any kind of set won't allow duplicate values, although that's less important for the discussion we're doing here. We then go ahead and warm up the thread pool, and then we do a whole bunch of different results here. And so let's start off just by having some fun. Let's go ahead and take a look at this method. This is print the first n distinct even numbers doubled. And we're going to use this as kind of the standing running operation to demonstrate all the different encounter order issues. So what we're going to do is we're going to take our collection, which in this case would come in as either a list or a set. We're going to turn it into a stream. We're going to make sure the results are distinct, which is real easy for a set because they're already distinct. For a list, we have to actually filter out duplicates. We're then only going to keep the even numbers by doing a little filter magic. We're going to double all the integers in the list. We're going to map all the integers into a string, only keep up to the first n of them, and then use the collect joining method we talked about before, that collector that goes ahead and puts everything into a single result. And then we go ahead and print out the first n even numbers of the results are blah. Okay, so that's kind of how that particular test is going to work. So we're going to run that test. It's going to run all this stuff, and you can see the results, and then we'll walk through the code, and you can see where the results came from. So it's hopefully up and running, cranking away. There we go. The thread pool's warmed up. And so out of all those numbers, we only print the first 10 of them. And hopefully you'll be able to see differences in the numbers. So you'll see that sometimes we enforce the encounter order and sometimes we ignore the encounter order. And I think you can get a good sense from just looking at the results here of what the encounter order is. So you can see, move myself down here, the encounter order is 292, 316, 212, 328, etc. That's the order in which the data was originally generated. And you'll see that whenever we do the operations that enforce the encounter order, that's the order of the output. When we start doing operations that ignore or don't enforce encounter order, we're going to get the results in different orders. So you can see here when we ignore encounter order, they don't come back in the encounter order. If we do a set, then the set also ignores the encounter order because it doesn't care about the encounter order. And then we're also going to do a bunch of tests demonstrating the performance consequences of either enforcing or not enforcing encounter order. And without spoiling the surprise too much, you'll see that the tests, the examples that don't bother enforcing encounter order tend to run faster, especially when we have parallel streams. So this is another good performance tip. If you want to speed up performance and order doesn't matter, then make sure you deorder your streams. And I'll show you how to deorder a stream here in a second. It's pretty cool. Okay, so that's kind of at a high level. So now let's go ahead and take a look at these various tests. So here's the first one. This is the run, test, and print result. This is just going to basically time the results so we figure out how long things take to run. So let's take a look at one of the things that enforces the encounter order. So here we're going to go ahead and say whether we're running in parallel or not, and we're also going to give ourselves a collection, which is either a list or a set. And what we're going to do is we're going to go ahead and make sure the items are distinct. So this is going to enforce the encounter order. We only keep the even numbers, we double them, and then we give ourselves back a stream that's an integer array. So let's go up here and see what we do when we call this. So you can see we call enforce encounter order. And you'll notice that for enforce encounter order, we pass in the list. And for the version that's going to be ignore encounter order, we're going to pass in the set. So what this is saying is lists inherently enforce the encounter order. And if you come over here and you look at the results, you can see that the encounter order is in fact enforced. And you can also see the difference in performance. So we have sequential versus parallel. If we're going to enforce the encounter order, you can see that those things take longer to run. And the enforced encounter order for sequential and parallel streams take this amount of time to run. Now let's go ahead and take a look at the ones that ignore the encounter order. And that's going to be sets. So in this particular case, we're going to pass a set in. We're going to use a belt and suspenders approach to say, hey, ignore this thing. This really is ignoring the encounter order. We don't care what the order is. And then we do the same operations as before. We ensure the results are distinct. We only keep the even numbers. And then we map the numbers to double them and then store them in an array. And what you'll see when you look at the results is, number one, the encounter order is ignored. And then number two, you can see that ignoring the encounter order is way, way, way faster. So ignoring encounter order is a lot faster than basically respecting the encounter order. So those are some other things to keep in mind. So that'll help make a difference. Let's go take a look at another test we have here. This next test, I think, is the limit test. So the limit test is going to take a look at showing that the use of the limit operation is much faster if the stream is unordered versus ordered, especially when we start dealing with parallel streams. So here we're going to pass in our collection. We're going to say whether we care about encounter order or not. We're going to say whether we want to run in parallel or not. So if it's unordered, then we're going to say make this stream unordered. If it's ordered, we leave it the way it is. If it's in the parallel flag is set, we want this to run in parallel. And then we go ahead and do the same logic. We ensure the elements are distinct. We only keep the even numbers. We double the number of elements in each part. And then we limit the number of items we're going to output, which I think in this case is 10. Let's take a look at the results. What you can see here is very interesting. The sequential versions, whether they're ordered or unordered, are blazingly fast. However, when we start going parallel, you can see that the relaxing the ordering, the encounter order requirements for parallel streams is really fast, whereas forcing ordering for the parallel streams version is really slow. So clearly having ordering enforced requires a lot more work to be done by the stream because it has to put the results back together in the order in which they were originally encountered, which is quite a lot of extra work in this particular case, especially when we have millions of elements and we only want to keep the first 10 of them. So it's obviously a lot faster to do it in an unordered way. And then the last thing we're going to look at is the use of a terminal operation or a pair of terminal operations, for each and for each ordered. So those are also operations that either respect or don't respect encounter order. Now, this really only makes sense for parallel streams. So everything here will be for parallel streams. So we're going to have a Boolean flag, whether we want to use for each ordered or unordered. And you can see what we're basically going to do here. So if we're going to do it unordered, we have a parallel stream, and we're going to go ahead and add each element into a concurrent linked queue. And there will be no pressure to order anything in this particular case. It's just the first 10 elements that show up in whatever order are the ones that are going to go into that queue. Conversely, here's the logic we have using for each ordered. So for each ordered, as you can see here, is a version of the for each terminal operation that has to respect the encounter order. And so we use for each ordered here, whereas up here we just use for each. Everything else is the same. And when you come over here and you take a look at the results, you can see that the for each test with unordered results, so we use the for each terminal operation, is very fast, whereas for each using the ordered results is correspondingly much slower. And that's because it has to synchronize things and rearrange them and all kinds of other good stuff. So it's just slower to execute. So these are some examples of some of the subtleties of using encounter order. Most of the time, if you don't care, just make it unordered, and then you won't pay the price. This is especially important when you start working with parallel streams. So let me go ahead and see if there's any questions. So can we ignore encounter order on lists, or are lists always obeying encounter order? So out of the box, encounter order is set by a list by default. So that's just the way it is. And most of the time, it doesn't really matter. The main place it would matter, I think, would be if you're doing things in parallel and you didn't really care the order in which things resulted, and you wanted to do something like either the for each example that we showed versus for each ordered, or we wanted to be able to do some kind of collector that didn't care about ordering, didn't worry about trying to reorder stuff. So in that case, you'd probably want to mark that particular stream as being unordered by using the .unordered intermediate operation, just as a way to indicate that you don't care about ordering. And so that would be the typical situation. Again, this really is only an issue when you're dealing with parallel streams. Do you have to use for each ordered with lists? No, you can use for each ordered with whatever you're iterating over. Terminal operations, as you recall, like for each and for each ordered, simply take each element in the stream and do some consumer action to it. So in the case of for each or for each ordered, there's a consumer. The consumer is often something like, system.out : println, which is a consumer. In this particular case, we used an add method for a concurrent linked queue, but it's whatever you want it to be. So it doesn't have to be a list by any means. Okay, so that was the topic. That was another topic I wanted to go over. This is encounter order. A bit of a mystery. You have to dig around a bit to see good explanations of encounter order. So hopefully this will help make things a little bit less mysterious for you.